Hello, second and eighth period algebra students. Mr. Lawrence here, and we've got a new lesson for you. This should be really easy stuff, especially those of you that know how to factor. Those of you that don't know how to factor, this will be your chance to get caught up. Anyway, here we go. Let's get on with this lesson. By the way, we'll be having a test next week, probably Wednesday, maybe Tuesday. All right, so the first question I have for you is name a multiplication problem that has a product of 0. Well, there's going to be lots of possible answers. Hopefully you're thinking of some right now, and one possible answer would be to have 3 times 0, right? Where you're multiplying any number times 0. Another possible answer would be to have 0 times -7, where you're multiplying 0 by any number, right? Either way. So what can we conclude from this? This is very important. Make sure you pay attention. The only way to have a multiplication problem equal 0 is if one of the factors is 0. Notice I highlighted or I italicized factors. Yes, we're going to be solving quadratics by factoring. I'm not going to be using the quadratic formula to solve these. It works, but I'm going to solve these by factoring. And it is very easy to do when you recognize the quadratic is factorable. Of course, you could always check the discriminant. If you get a perfect square for the discriminant, then the expression can be factored. So, before I actually get down to the factoring, let's see how it works. So, I've got this quantity of x plus 7 times the quantity of 3x minus 4. Now, if you paid attention just a few minutes ago, we need one of these two factors to be equal to 0. If one of the two factors equals 0, then the whole thing equals 0. Well, what are the two factors? And some of you are going to say x and 7. No, no. X plus 7 is one of the factors, right? The other factor is 3x minus 4. Well, how do I know when they're equal to 0? This is the easy part. This is so simple. Please don't make this hard. I'm going to take each factor, first the x plus 7, I'm going to set it equal to 0. Then I'm going to take the 3x minus 4, set it equal to 0. What am I going to do? I'm going to solve both of them for x. So I'm going to subtract 7 here, subtract 7 here. You should be taking notes on this. If you need the president to pause the video, that's fine. X equals -7. All right. How about over here? I'm going to add 4 to both sides. And I'm going to get 3x equals 4. I'm going to divide by 3, so x is going to equal 4/3. Or you could say 1 1/3. I'm not going to go to the decimal on this, but if you did, it would be a 1 3/10 repeating. Don't round it. Okay, what that means is if I put -7 in for x into the original problem, or if I put 1 1/3 in for x in the original problem, I will get 0 out. Yeah, it's guaranteed. Real simple. Let's see a couple more like that. At least one more. All right. I want you to pause the video now, and I want everybody to attempt to solve this. Tell me when this polynomial will end up equaling 0. Okay, here comes my solution. So, I see two factors. I see the factor 5x plus 1. And I see the factor of 2x minus 7. I'm going to find out when the yellow factor equals 0, and I'm going to find out when the blue factor equals 0. So I'm going to take 5x plus 1, set it equal to 0, and I'm going to take 2x minus 7 and set them equal to 0. I'm going to get x alone, subtract 1 from both sides, yielding 5x equals -1. Divide by 5, divide by 5. X is going to equal -1/5. That's one possible answer. 2x minus 7, I'm going to add 7 to both sides, and so I'll get 2x equals 7. I'm going to divide by 2, and x is going to equal 7/2 or 3.5. Okay, there are the two possible answers. If I were to double distribute these two quantities, I would get what? 10x squared plus 2x, right, minus 35x, minus 7, and if I combined like terms, I'd have 10x squared minus 33x minus 7 equals 0. If I were to plug in either 3.5 or negative 1/5 into this polynomial, I guarantee you will get 0 out. Feel free to check it, okay? All right, so let's see here. Excuse me. So now we're going to try and do it with some actual problems where we have to factor them, okay? If you were one of the kids that took the factoring unit seriously, these will not be so bad, all right? So if you didn't, well, now you have a chance to learn some factoring. All right, well, on problem number 1 here. I know the first type of factoring I should always try is GCF, and I see a GCF of x. So I'm going to factor out an x. And then I'm going to have an x minus 4 left. Now, I have a binomial on the inside. There's no GCF. Is it the difference of perfect squares? Is it a perfect square minus a perfect square? Well, 4 is a perfect square, but x is not. So no, it's not the difference of perfect squares, so this cannot be factored any further. So I have two factors. I have this x minus 4, and I also have an x. I'm going to set each factor equal to 0 and get x alone. So I'll have x equals 0, and I'll do x minus 4 equals 0. Now, Mr. Kirkwood, don't let this first one confuse you. We set the yellow factor equal to 0, right? X equals 0. What's x, Ryan? Yeah, of course, it's 0. Very good. Okay, now I have x minus 4 equals 0. You should be solving and get x equals 4. So the two answers are 0 and 4. That's the two numbers that will make the original polynomial equal to 0. You can test it, put 0 in here, you get 0 squared, minus 4 times 0. Well, that's 0, right? And if I put 4 in, I get 4 squared, which is 16, minus 4 times 4, which is 16. 16 minus 16, it equals 0. There you go. There's your two answers. All right, why don't you pause the video, see if you can do number 2. Here comes my solution. If you haven't attempted yet, please pause the video now. All right, I look for a GCF. The only GCF I see is 1. It's a binomial, so I check to see if they're both perfect squares. Well, let's see. 9x squared is a perfect square. Its square root is 3x. 25 is a perfect square. Its square root is 5. So this is going to be a 3x and a 5 in one quantity, a 3x and a 5 in the other quantity, and then I got to decide on my signs. Well, the c term is negative, so I'm going to need one of each sign. So I'll do a plus and a minus, just like that. All right, let's see if I can find my factors. So I have a 3x plus 5 as one of my factors, and I also have a 3x minus 5 as one of my factors. So, sorry, having a little technical difficulty here. So I'm going to take 3x plus 5, set it equal to 0, and solve for x. And I'm going to take 3x minus 5, set it equal to 0, and solve for x. So I'm going to subtract 5 from both sides. 3x equals negative 5. Got a little lag going on here. Going to divide by 3. And so x should equal negative 5/3 or negative 1 2/3. Okay? Over here, I'm going to add 5 to both sides. And I should get 3x equals 5, dividing by 3 on both sides, and I will get x equals a positive 5/3. Okay? So if I want to use the quadratic formula on this, I would get the same answers. Quadratic formula is one way to solve quadratics. Solving by factoring works if the discriminant were to be a perfect square. All right, try number 3 on your own. Go ahead and pause the video. When you're ready, unpause it and see my solution. All right, first thing I'm going to do is factor out a GCF. I see an x there, so I'm going to have an x squared, a minus 12x, and a plus 36. Now, inside the quantity, I have a trinomial. First thing I do with the trinomial is see, is it a perfect square trinomial? Because if it is, this is an easy factor. So, is x squared a perfect square? Sure is. I get x. Is 36 a perfect square? Yeah. Square root is 6. Now I multiply the two square roots together, I get 6x. Double it, I get 12x. This is a perfect square trinomial. So I'm going to have x times the quantities, and I will have x and a 6, and x and a 6. I look at the c term, it's positive, which means both signs are the same. Which sign do I use? I use B's sign. Both signs are negative. So, I see 3 factors this time, except the one factor is duplicated. So I'm actually only going to have 2 answers. But I see this term, this factor, I see this factor, and I also see this factor. Potentially I could have 3 answers on this one. It's not a quadratic, it's actually a cubic if you look at it. But I'll only have 2 because the one factor shows up twice. So I take the yellow factor, set it equal to 0. I take the green factor, set it equal to 0. And I don't have to waste my time doing it with the blue factor because it's the same as the green one. So on this one, all I have to do is solve for x. On the yellow one, it's already solved. X is already alone. And so my 2 answers are x equals 0 and x equals 6. There you go. All right, I think I've got one more example here. Let me get rid of this screen here. Go away. Not going. There it goes. Oh, there's 2 more examples. So maybe I should just pull the screen down. Let me just get rid of it. Okay. So the first one, it's a trinomial. It's not a perfect square trinomial because 6x squared is not a perfect square. So I'm going to go check the discriminant, make sure it can be factored. All right. So A, B, C. Easy as 6, 1, negative 15. All right, so 1 squared minus 4 AC. And so we get 1, we get a plus. I got a 24 times a 15. Let's see, that's be the same as 72 times 5. That's going to be 360. And so that's 361. And because I know my perfect squares, because I had to learn them earlier, I know that that is a perfect square and the square root is 19. So this is factorable. So let me get myself some room here. Now, since it's trinomial and it is factorable, what I'm going to do is I'm going to list the factors of A. Quit lagging. Oh my goodness, this is driving me nuts. All right, so I'm going to list the factors of 6 and of 15. So I list the factors of 6. I'm going to get 1 and 6. I'm going to get 2 and 3. And for 15, I'm going to get 1 and 15. And I'm going to get 3 and 5. And now I'm going to multiply the factors together, 1 from 6 and 1 from 15, right? And multiply their partners together. And then I have to subtract to get 1. Why subtract? Because the 15 is negative. So let's see here. I've got a 15 and a 6. It looks like I've got a 9 and a 10. 3 times 3 is 9. 2 times 5 is 10. And I want a positive 1, so it's going to be a negative 9 and a positive 10. Right? That'll give me a positive 1. So now I'm ready to factor. So I'm going to have a 2x and a 3x. Now, so many of you just chose to not use my loops. I got the big loop, and I got the little loop. If you choose to not use them, there's really nothing I can do to help you. I show you a technique, you don't want to use it. Those of you that are using it, I'll be more than happy to help you with any difficulties. So let's see, I multiply the 2 by the 5, so I multiply the 2x by a 5. Now when I multiply that, I get 10, don't I? And I want a positive 10, so I know it needs to be a positive 5. What did I multiply the 3 by? Well, another 3. So this 3x gets multiplied by a 3. I want it to be a negative, so it'll be a negative 3. Why do I want it to be a negative? Because of that negative 9 right there. Yeah. All right, one more example, and then you can get started on the homework. Now, by the way, I will post this video, not that too many of you will watch it over the weekend. It might be a real smart idea, but I know you'll forget about it. Okay, so I don't have a perfect square trinomial. I'm going to go ahead and check the discriminant, make sure it's factorable. If it's not factorable, I'm going to have to use the quadratic formula. But if it is factorable, then I can factor it and solve it that way. All right, so let's see here. What is that? 361, right? Plus 12 times 14. 14 triples, 42, 84, 168, I think. And I'm a vertical kind of guy, so I'm going to write it down here. All right. And when I add those, I'm going to get a 9, a 2, and a 5. I think 529 is a perfect square. I want to say 23. If I do 23 times 23, if I multiply those, I think I'm going to get 529. There's going to be 9. 6 and 6 is 12. Carry the 1, 4, and 5. Yeah, it is 529. It's a perfect square. So I'm going to list the factors of 14 because I know it's factorable. 1 and 14, 2 and 7, 1 and 3. Now I'm going to multiply the factors together and subtract their products to get 19. Oh, look at this. I got 21 right here. Right? There's a positive 21. And then I'm going to, whoa, I don't know what just happened there. I was trying to circle the 1 and something bizarre happened, but like I said, I think this airliner's on its last legs. So this is going to be a positive 21 and a negative 2. That'll get me a positive 19. So I break up my two quantities. I'll have 2x leading that quantity, and leading the second quantity, I'll have a 7x. Right? I do my big loop. I do my little loop. And I say, what did I multiply the 7 by? A 3. So I put the 3 here. 21's positive, so I make it a positive 3. Multiply the 2x by a 1. I need a negative 2, so I'll use a negative 1. And that's factored. Oh, did I forget to solve on the last problem? I think I did. All right, so let's back up a little bit here. I factored it, and then I just moved on. Pardon me. I forgot to make it equal 0. Well, I'll tell you what, I'll finish 5, and then I'll go back to 4. So I'm not jumping around too much. All right, so I see my two factors. They happen to be 2x plus 3, and my other factor is 7x minus 1. So when I 2x plus 3 equals 0, and you should have gotten x equals negative 1.5 or negative 3 over 2. I'll leave the details up to you on that one. The second one, you should have 7x minus 1 equals 0. And again, I'll leave the details to you. X will equal 1/7. there are your two solutions. Negative 3/2 or negative 1/2 and a positive 1/7. All right, let's back up to number 4 here. I forgot to leave that equal to 0. I've got my two factors. There's 1. There's 2. So setting them equal to 0, I should get 2x minus 3 equals 0. When I solve for that, I'm going to get a positive 1/2 or a positive 3/2. And the second one will be 3x plus 5 equals 0. And solving that, I should get x equals negative 5/3, or you could tell me negative 1 2/3. All right, that's it for the video. With the remainder of time, you should be working on your homework in Math Excel. And then if you need to, please rewatch the video at home. All right, Mr. Lawrence signing off. Have a good night, everybody.